Hi everyone, welcome to Outcome R1, Factoring Quadratics. This is section 4.2 in your textbook. We're going to look at factoring. We're also going to talk about the idea of solving equations, quadratic equations, and finding the solutions. And we're going to discover what that means. If you are a little rusty on factoring from what we did in grade 10, then I'm going to recommend that before watching this video, you should go back and watch the grade 10 factoring video that we have, and you can find a link to it just around where you came to this video. Okay, so let's get going with this stuff. All right, so factoring quadratics. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c. This is a second degree equation. We can see that because we have a power of 2 on this x right here. And a, b, and c, these variables are constants, and a is not allowed to be 0, because if you think if a was 0, well, geez, that would just be a linear equation, right? Now, the graphs of these quadratics are in the shape of a parabola. So we know what a parabola is from chapter 3, and it looks like a bell or a rainbow or U-shaped, right? Depending on whether our a value is positive or negative. Now, if we look at this picture of a quadratic, this is a quadratic that has a positive a value. We know that because it is opening upwards. We want to look at what the X intercepts are. That's the important thing here. All we're doing is we're solving to find the X intercepts. So if we look right here, this is an X intercept, because it crosses the x-axis. See, this is the x-axis right here. And this is another x-intercept. This is also where the graph crosses the x-axis. So if we look at where the values of our x-intercepts are, we can approximately see that this one is around 0.4 probably. It's not quite the half mark, maybe 0.3. We're just reading it off the graph, so it's approximate. And then the one right here, we could say that that one is at 5.7, 5.6, something like that. So that's our x-intercepts. Now let's look at the next one. Okay, so carefully look at this graph. Make sure you see that the x-axis is right there. So our x-intercepts are right here. And I'm going to say that is at like negative 3.1. And our other x-intercept is right there, and we can say that that's positive 3.1. All right, now you're going to see this again and again, and it says solve. So what you're doing is you're solving this quadratic equation. The first step is already done for you. It's already been factored out. Okay, so do not multiply this through. Please, warning, do not multiply this through. All right, so the first thing that we're going to do is we want to know where this equation crosses the x-axis. And we know that the value of our y, so normally we'd have a y right here, right? But instead we have a 0 because we have set y equal to 0, and that is where we find our x-intercepts. So that's what we're trying to do. So all you want to do is you want to take each bracket and you want to set it equal to 0. Okay, so let's do the first one here. X minus 9 equals 0, and then you have x plus 3 equals 0. So now we've taken both brackets and we've set them equal to 0. Now what you're going to do is you're going to take each of those and solve them independently. So for this one here, for this one right here, we're going to solve and we're going to move the 9 over. So you add 9 on both sides and you end up with x equals 9. And for this next one right here, we are going to have x equals -3. You subtract 3 on both sides. All right, let's go to the next one. This question here, be careful, there are 2 brackets, but one factor doesn't have a bracket around it. You see this x right here? This we need to make sure that we have it as a factor and you set it to 0. So let's work that one over there. Say x is equal to 0. And then we're going to take this one and we're going to say x plus 12 is equal to 0. Okay, now this side here is already done. So we know that the graph is going to cross at x equals 0. So we need to look at this one and figure this one out. So this is pretty easy. X is equal to -12. This next question here, well, we have to do the first step, right? We have to factor it out. So if you can't remember how to factor, then it's really important you remember how to factor. So let's factor it. We want to look for 2 numbers that multiply to 28, -28. That'll in fact add up to +3. All right, so 7 and 4 will do that, and we need the x, we need it to be +7, and we need the 4 to be a negative, and then when you add those 2 numbers together, your +7 and your -4, you do indeed end up with your +3. Okay, so now we set each bracket to 0, x plus 7 equals 0, and x minus 4 equals 0, and solve for x. So here we've got an x-intercept of -7, and we've got an x-intercept of +4. All right, so I'm going to dare you right here. I'm going to dare you to pause the video and give this one a try. Remember, factor, then set each factor to 0. Okay, so now that you've given it a try, I want to, let's run through it. X, factor the x out, you're left with x minus 7 equals 0. One of the x-intercepts is 0, and the other x-intercept should be 7. Yay! Give yourself a round of applause or pat on the back if you got this right. All right, so the answers to a quadratic equation, they're also called solutions. This means the exact same thing as solving for x or the x-intercepts. There's like 3 different ways to say the exact same idea. Okay, so now what I want you to do is completely factor the following. And this is really unfortunate that we have this type equation here. I didn't notice that before. But you know what? We're going to go with it. If you remember, this is a difference of squared question. So let's factor it, and we end up with 4x plus 5y and 4x minus 5y. All right, so all we're doing is factoring. And the next question, we've got 9x squared minus y squared divided by 100. Okay, so now just carefully look at this. Make sure you realize that this is a square, so that's 3 squared and that's x squared. And this is also a square, even though it looks a little funny. This is y squared. And then what is 100? Well, that's 10 squared. And we've got a difference. So this is indeed a difference of squared question. So press pause and give this a shot. It's okay to make mistakes. Try it on your own. You might already know how to do it. Okay, so let's see. So hopefully you're fast at pressing the pause button and try this question. If not, well, I guess spoiler alert, the answer's here. So it's pretty much exactly what I said when I read it out, right? Like here you've got the 3x and the 3x. That 3x squared is 9x squared, and we've got a minus and a plus here because that's a difference of squares, and your y squared becomes y times y, and then you're divided by 100 bit. gets broken up to a 10 and a 10. All right, now this looks like a bit of a different beast, right? Now you've got all this plus x plus 3 stuff and x plus 3 stuff here. When we learned how to factor, we didn't really see anything like this. We would normally see a question that actually would look like 2 and then maybe a squared minus 11, a plus 15, right? Okay, so we can factor that question, but when it looks like this, it changes it a bit. Okay, warning, please do not multiply this through. Don't expand. You're going to waste so much time doing that. What I want you to do is a lot quicker. What I'd like you to do is make a substitution, and by that, say let a equal x plus 3. Then, in fact, what you're going to do is you're going to make it look exactly like this question here. You see, if you just plunked this x plus 3 in this a here and here, you end up with the exact same thing. Now, this question over here that I have up in red, that's a lot easier to solve for, right? Now, you just have to remember how to do decomposition, because it might be a little, you know, remembering how to factor and all that. So let's actually see what it looks like when it's factored. So we end up with 2a minus 5. If you're just guessing and checking, just make sure that you remember to check it. All right, so I'm gonna make that bracket a little nicer. All right, so then when you're checking it, let's see, this gives you minus 5a, and then this gives you minus 6a, and that adds up to minus 11a. Now, we're not done the question. You have to go back and you have to say, remember this business here? X, that a equals x plus 3. What you want to do is you want to put that x plus 3 back into it, and then you're going to end up with your bracket 2. Instead of the a, we're going to write x plus 3 minus 5, and then get your other bracket. And this is the substitution for a minus 3. Okay, so now what I want you to do is hit pause and multiply this 2 through the bracket and simplify it with this minus 5. And I want you to simplify this bracket and leave your answer in just 2 brackets, okay? That's what you want to end up with. Okay, so hopefully you were quick with that pause button. You can see here that I multiplied this 2 through the bracket, end up with 2x plus 6. Then you have that minus 5 there. I just removed the bracket here because there's nothing to expand through. And simplified each bracket here, so then you end up with 2x plus 1 times x. Now, if you decide to be crazy and multiply this junk through, you will end up with the same answer at the end if everything goes correctly. You will have just, however, wasted a whole bunch of time. Okay, now we have a question with a 1/4 out in front, and that's where this can get a little bit challenging. You have to just think, what it means to factor. You're basically wanting to pull out this 1/4, and then how is it going to impact? You want to end up getting back to the answer when you multiply that 1/4 back in. So what happens when you factor out that 1/4 is, well, how am I going to get back to x squared? 1/4 x squared, I'm going to multiply an x squared with that, right? Now, what number do I have to multiply 1/4 with in order to end up with a negative x? And that number is going to be a 4. So if I multiply 1/4 times 4, I end up with 1. Okay, good. Keep going. Now, same thing with this minus 3. my answer is going to be 12. So just double check when you're doing these questions that when you multiply this back through, you do indeed end up with these numbers here. So 1/4 times x squared, that's going to give me 1/4 x squared. 1/4 times -4x, that is indeed going to give me -1x. 1/4 times -12, that's going to indeed give me -3. Okay, so now you see this part here in this bracket, much easier to factor. So hit pause now and finish the question. All right, here you go. So this is what your answer should end up looking like. 1/4 times x plus 2 times x minus 6. Double check it to make sure it works. Okay, let's go on to the next one. Oh my goodness, decimals. What do I do with decimals? Okay, really, forget about the whole decimal thing and look at what this number is, 64. Have you seen this before? Is it any kind of special number? Why, yes it is. It's a perfect squared. It's actually 8 squared. So this is just a difference of squared question again. It's just looking a little different to just play with your brain a little, extend it further. So it's not always the same, because in real life, numbers get a little hairy sometimes. So we've got 9x squared. I'm going to break that 9x squared. I already know it's going to be difference of squared, okay? So, look like that. You got a minus, a plus, an x here, and a y there, an x here, and a y there. And my 9 breaks up to be 3. And my 0.64, well, that's actually 0.8 squared. So this is 0.8 and 0.8 there and there. Done. Factored. Okay, so now it's your turn. Really, I want you to hit pause. I want you to try to do these questions. So if you haven't hit pause now, then hit pause already. Okay, so hopefully you press pause. If not, you still have a chance before I reveal. Okay, so your turn right here to factor this. The trick is take out this 1/2 and you end up with 1, a -2, and a -8. And if you multiply each of those coefficients by a half, you end up back at a half, -1, and -4. And then you have your final answer right here, all factored out nicely. Okay. Next question we're going to look at right here. Now, you notice this 0.7 squared gives you 0.49. So, and 36, well, we know that's 6 squared. So there's your difference of squared question again. And you end up with 0.7y minus 6x, 0.7y plus 6x as your factors. All right, so now here's our next question. We've got 3x plus 1 all squared minus 2x minus 3 all squared. Now, here's the thing. Looks a little different from what you've seen before, right? This here, well, this is something. And this here, that's another something. So you have something squared minus something else squared. That's a difference of squared, people. Okay, so here, I color-coded it for you so you could follow it along a little better. You've got your 3x plus 1 in red here, and you've got your 2x minus 3 here, and notice you got a minus in between that bracket, and then you've got your 3x plus 1, and your 2x minus 3, and your plus. So this is a beautiful difference of squared question. It's just disguised because we're not used to seeing a polynomial inside those two places. So It's a little confusing. Now here in this next step, if you notice, this is the blue and the red blended together to make a beautiful purple. And the reason I did that was to show you that we just simplify this. We multiply this negative through and we end up with that. And we simplify this here and it gives us 3x plus 1 plus 2x minus 3. And when we simplify combined like terms, we end up with a 1x there. You take that 1 and that 3, you get a 4. Here, 3x plus 2x gives you the 5x, and your 1 and your negative 3 give you your minus 2. So this is your final solution to factoring that question. All right, now, sorry. Okay, here's your next one. This is the kind of question that we did earlier where you had to substitute. So we've got our substitution here, and we're letting a equal n plus 3 just so that it could look a little nicer. Okay, once you've done that, factor out your negative 2. Make sure you actually factor the negative out, and just double check those little things because they're very important. And now this is a lot easier to factor, and you get a minus 7 times a plus 1. Once you're at that point, you want to sub back in your n plus 3 equal a, and that's done right here. And then you just simplify anything that can be simplified, and this gives you your final answer right there. Okay, so now we have another type of question where we have to determine the roots of the following equation. Now, the difference here now is we've got an equal sign, therefore we are calling them equations. So the trick here, or the thing that you need to do, is you need to make sure that you set your equation equal to 0. So if it isn't equal to 0, you need to do something to make it equal to 0. And then you would do the same thing as what we were just doing before, factoring and then solving. So let's step right into it. We end up with x squared plus x minus 6 equals 0, because you just take the 6 and you subtract it on both sides. And then you factor this, and we end up with x minus 2 and x plus 3. And if we take each bracket, set it to 0, and solve it, well, here we get x equals 2 and x equals negative 3. And that's all there is to it. Everything else is going to be the same. So why don't you give the next question a try, hit pause, and I'll just show you the solution, okay? Okay, so now we're this far. We've factored our common factor of 2 out, and then we have this here, and it's easier to factor. We end up with 2 times x plus 4 times x minus 3. So now from this point, we're going to take each bracket, we're going to set it equal to 0, and then we are going to solve each one of those equations and end up with our answer. So here we get x is equal to negative 4 and x is equal to positive 3. And this is where this equation, this parabola, this graph, if this were to be a graph of a quadratic, would cross the x-axis at x equals negative 4 and x equals positive 3. Okay, we're going to do the same thing here. Hit pause. You try this question first, because it's always good to have the practice for factoring. The more you do, the better you're going to learn it. All right, so now here we've correctly moved over this negative 3x squared over to this side, making the right-hand side equal to 0. And then we have successfully factored it. Just do your double check. That gives you -2. This gives you +6. And together that gives you +4. All right, done. Awesome. Now, the next step that we're going to do is we're going to set each bracket equal to 0. 3x minus 2 equals 0. And x plus 2 equals 0. And then you're going to solve each so that you get x. So x is equal to 2 over 3. And here, x is equal to -2. So there's one of the x-intercepts and the other x-intercept. Just more of the same, folks. Keep going, hit pause, you try this, then I'll reveal. So hopefully you're quick with that pause button. Actually, really, you only need to tap the screen, right? Okay, so here we get the answer of, well, you move the 18 over, so it becomes your -18 here. Then factor this, you get 4x plus 3, x minus 6 equals 0. Set each bracket equal to 0, and then solve each equation to get what your x will be. Okay, let's go to the next one. Okay, only 3 more to go, including this one. If you want, try the rest of them and then just scroll through the rest of it. Okay, so hopefully you notice that there's this 1 over 12 business that you need to deal with. And to do that, we need to factor out the 1/12. You end up multiplying a 36 by 1/12 to get back to the 3. So that's why this is 36. And this is a -1 when you factor out the 1/12 there. So we end up with a nice little difference of squares question as well here. So you've got your 6x minus 1 for the first factor, 6x plus 1 for your other factor with your 1/12 out here. Now this is all equal to 0. So we take our first bracket and we set it equal to 0, solve for it, x, and we end up getting 1 over 6. We take our second bracket here, which is 6x plus 1, set it equal to 0, and we get our answer of x equals -1 over 6, thereby giving you your solutions. Okay, so give yourself a chance with this question. Now, just be careful. It's decimals. It's just, they're all numbers. Don't worry about it. Just think in terms of, I need to factor out this 0.5, or if you want, convert it to fractions, factor out the 1/2, and then deal with it. Okay, so here's the reveal for this one. You factor out the 0.5, you end up with x squared and -0.04. Factor that difference squares out, you end up with your 2 brackets equaling to 0, and your solution is x equals 0.2 and x equals -0.2. If you got this, be very proud of yourself. The next question, I'm just think about what needs to be done. Here, I'll show you. Okay, so you're looking at this question and you see a couple of brackets, but be careful because it's not equal to 0. So what do you need to do? You need to make this side equal to 0. So indeed, what you're going to do is multiply this through and then move the 24 over so that you have it set equal to 0. Okay, hit pause, try it, see where you end up. Okay, finally, the last question. Here's the reveal. Multiply the brackets through, simplify it. You end up with x squared plus x minus 6, and then that is equal to 24. Take your 24, subtract it on both sides. You end up with x squared plus x minus 30 equals 0. factor that, it's a simple factoring question, you have x plus 6 and x minus 5, and that is equal to 0. Set each bracket equal to 0, and you end up with x equals negative 6 and x equals 5. Okay, so be very proud of yourself for getting through that. Those were a lot of questions, but you need a lot of practice to get very good at this stuff. So have fun, do the questions from the textbook, and ask questions when you need. Okay, practice, practice, practice.